I'll confess, I can't remember the last time an astronomical story triggered such a sense of urgency. Over the past few days, internal channels between observatories and science newsrooms have been buzzing with messages, preprints, hypotheses, rebuttals, graphs sent in the middle of the night, emails with all caps subject lines. Everything revolves around a tiny dot crossing through our solar system that apparently refuses to behave as it should. What's this all about? Well, you'll find out in the next 13 minutes. You know that endless list of books, podcasts, and articles you meant to get to? I had the same problem until I found Shortform. Now, instead of feeling behind, I'm finally catching up. They've got the best in-depth book guides, but it doesn't stop there. You also get master guides that combine multiple books into one clear overview, summaries of articles and podcasts, and even a browser extension that can summarize anything online, even YouTube videos and research papers. It feels like having a personal research assistant in your pocket. I recently used it to catch up on Psychology and Decision-Making with Thinking, Fast and Slow by Daniel Kahneman. In just minutes, I had the key takeaways plus perspectives from newer works like Noise, which built on the same research. It saved me hours of reading while still giving me depth. So if you want to learn smarter, not harder, check out Shortform. Head to shortform.com/insane for a free trial plus 3 months off when you sign up for the annual plan. I'm talking about the interstellar comet 3I Atlas, the third object ever identified as coming from outside our system, and with everything it's revealing bit by bit. Like a poker hand slowly being played, it's spreading amazement, excitement, and skepticism throughout the scientific community. They call it a comet by convention, but the definition, many say, is already creaking under the weight of the data. For weeks now, telescopes like Hubble, Sphere-X, JWST, and even TESS, designed for completely different purposes, have been observing it at every possible wavelength. And almost every time, the results that come back show a small deviation from predictions, a minimal but significant variance, something suggesting that 3I Atlas's story is more intricate than we thought. But let's start from the beginning. On July 1st, 2025, the Atlas Alert System in Rio Hurtado, Chile, spots what appears to be yet another comet. But something doesn't add up. Orbital calculations show this object isn't orbiting our sun. It's coming from outside, from interstellar space. It's only the third visitor of this type we've managed to identify with certainty after Oumuamua in 2017, that cigar-shaped object that caused such a stir, and Borisov in 2019. But here's the first oddity. When astronomers went back to check old images from the TESS Space Telescope, they discovered the comet was already visible in May when it was 6 times the Earth-Sun distance, about 560 million miles or 900 million kilometers away. And here's what you need to understand. Comets at that distance are normally dormant ice balls, invisible. But Atlas was already active, already surrounded by a cloud of gas, as if it had switched on too early, violating the rules of the game we thought we knew. When the James Webb Space Telescope pointed its powerful infrared eyes at Atlas, scientists' jaws dropped. The comet was primarily expelling carbon dioxide, not water vapor as you'd expect. To put it in perspective, it's like discovering that instead of normal exhaust fumes, a car is emitting rose perfume. Technically possible, but definitely weird. The ratio of carbon dioxide to water turned out to be 8-to-1. In our solar system's comets, even those rich in carbon dioxide, this ratio rarely exceeds 1-to-1. It's as if Atlas came from a place where the rules of cometary chemistry are completely different. Scientists started wondering, what kind of star system did this thing form in? But it wasn't over. The spectrograph showed intense lines of atomic nickel, while iron seemed almost absent. In all solar system comets, these two elements appear together in similar proportions. Here, not so much. As if the comet had been selectively distilled, or as if it came from an environment where iron never had a chance to condense. Cosmic chemistry experts talk about a differentiated nucleus, where metal-rich zones have been removed or destroyed. But others, more cautious, suspect we're observing surface phenomena we don't yet understand. an interaction between radiation, gas, and dust that mimics that anomaly without really implying an exotic origin. Yet every attempt to normalize 3I Atlas ends up failing. Polarimetry data from the Very Large Telescope added another paradox. The reflected light showed an incredibly deep negative polarization branch, with an inversion at 17 degrees, a combination never seen in any other comet. It's as if the comma particles were made of something completely different. Hollow grains, perhaps, or porous dust capable of scattering light chaotically. Every hypothesis seems more absurd than the last, yet the data is there, solid, verifiable, replicated by different observers. As weeks passed, the comet continued to amaze. During the lunar eclipse on September 7th, several astrophotographers noticed a sudden color change. The comma, which had been reddish until then, had turned an intense, almost iridescent green. This phenomenon is usually linked to carbon molecules, but Atlas contains very little carbon. Some scientists talk about non-linear photochemical processes, others about thermal fluctuations releasing trapped gases. But in the more heated discussion forums, even among researchers, a question circulates that no one dares ask openly. What if the comet is genuinely more complex than we imagine? Not artificial, as sensationalist blogs suggest, but equipped with physical mechanisms not yet cataloged, a legacy of birth conditions that challenge our parameters. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. But the real bombshell comes when a Harvard team led by Avi Loeb, the Harvard astrophysicist known for his provocative ideas about aliens, decides to crunch some numbers. They start collecting data from 227 observatories worldwide, thousands of precise measurements of the comet's position. Their goal? To figure out how massive it is. You see, when a comet approaches the sun and starts puffing gas like a dragon, these jets act like tiny rocket engines that push it slightly off course. It's a minuscule but measurable effect. The lighter the comet, the more these jets deflect it. It's pure physics. Try blowing on a soccer ball and then on a bowling ball. Which one moves more? Well, Atlas barely budges. Despite losing 330 pounds or 150 kilograms of material per second, the equivalent of a small car evaporating every minute, its trajectory remains almost undisturbed. The conclusion is that this comet, to remain indifferent to the thrust of degassing, must weigh at least 33 billion tons or 30 billion metric tons. That's 3,000 times more massive than Borisov and 300,000 times more massive than Oumuamua. And faced with this data, Avi Loeb didn't hesitate to raise a question that sent chills down many colleagues' spines. If Atlas is really this big, where are all the smaller objects we should have discovered by now? The ones the size of Oumuamua and Borisov. Put like that, it might not seem to make much sense, but let me explain the problem with an analogy. Imagine fishing in a lake. Logic tells you that you should catch hundreds of minnows before pulling up a shark. Yet in the case of interstellar objects, we caught a medium fish first, Oumuamua, then a small one, Borisov, and now a sea monster, Atlas. According to the laws of statistics and what we know about the size distribution of space objects, we should have seen at least 100,000 small interstellar visitors before encountering one this large. 100,000. And instead, we've seen only 2. It's like winning the lottery 3 times in a row. Technically possible, but suspiciously improbable. And here's where Loeb drops the media bombshell that went around the world. We should at least consider the possibility that it's not a natural object. Now, before you jump out of your seat, let me clarify. Loeb isn't saying it's an alien spaceship. He's saying we have an object that violates so many expectations that we should at least check if it shows signs of artificiality. It's the difference between crying wolf and saying, that dog is strangely large, let's make sure it's really a dog. Obviously, such statements couldn't go unnoticed. Tom Statler, NASA's lead scientist for small solar system bodies, promptly intervened to throw cold water on the fire. Look, this thing looks like a comet, behaves like a comet, does all the things comets do. It's just a bit eccentric, like that weird cousin we all have in the family. NASA emphasized that there are perfectly natural explanations for all the anomalies. The weird chemistry, it could have formed in a star system with different element proportions than ours. The enormous size, maybe small objects disintegrate during interstellar journeys and only the big ones survive. The anomalous nickel, there are natural processes that can separate metals under extreme conditions. But even the skeptics admit we've never seen anything like this. At this point, if you'll allow me, I'd like to bring some order to this whole affair. Based on the data presented, my opinion is that there are 3 truly substantial anomalies that make 3i Atlas genuinely strange, plus some minor peculiarities that amplify the mystery. The serious anomalies. 1. The completely whacked out chemistry. The CO2-H2O ratio of 8:1 is truly extreme. It's not just a bit high, it's off the charts compared to any known comet. This suggests it formed under radically different conditions, perhaps in a star system with temperatures and pressures we've never modeled, or near a star with very different characteristics from our Sun. 2. The never-before-seen light polarization. This is perhaps the hardest and most inexplicable data point. Polarization depends on the physical structure of dust grains, their shape, porosity, composition. Atlas's values, -2.7 with inversion at 17 degrees, are literally off the charts. It's as if the dust has a crystalline structure or geometry that doesn't exist in our solar system. 3. The statistical paradox of its mass. If it really weighs 33 billion tons, there's a serious mathematical problem. It's like finding a whale in a pond where you've only caught 2 minnows. Statistics say it's almost impossible, unless our calculations about the interstellar population are completely wrong. There's a mechanism that destroys small objects but preserves large ones. Atlas belongs to a completely different population. The additional oddities. Early activity visible at 6 AU or 560 million miles. Strange but explainable with all that CO2. Anomalous nickel. Curious but not decisive. Near perfect alignment with the ecliptic plane. The probability of this happening by chance? 1 in 500. It's like throwing a dart blindfolded and hitting the bullseye on the first try. My interpretation. I believe Atlas is genuinely anomalous for natural reasons we don't yet understand. I don't think it's artificial. There's no concrete evidence like radio signals or impossible accelerations. But it's clearly an object that formed under very different conditions than what we know. The real mystery for me is, does it come from a star system with radically different chemistry? Or did it undergo processes during its interstellar journey that we've never considered? The fascinating thing is that it's challenging not 1 but 3 different fields: cometary chemistry, cosmic dust physics, and interstellar population models. When a single object manages to create problems in so many disciplines, it means there's something really important we don't understand. It's a bit like when they discovered the first platypuses. They seemed so impossible that some scientists thought it was a hoax. Atlas could be the platypus of comets, something perfectly natural that we simply never imagined could exist. At this point, you might ask, why all this fuss over a space snowball? The answer is that Atlas is forcing us to confront the limits of our knowledge. Every anomaly it shows is like a crack in the wall of our scientific certainties. If it's natural, it's telling us the universe out there is much more varied and strange than we imagined. That there are planetary and cometary formation processes we've never considered. That cosmic chemistry can produce objects that violate all our expectations. If instead, and I emphasize if, it weren't natural, well, that would be the most important discovery in human history. Proof that we're not alone. That out there someone is advanced enough to build objects that can travel between stars. The future. What happens now? As I'm preparing the script for this video, Atlas is silently gliding towards its appointment with the Sun. In a few weeks, it will disappear behind our star, only to re-emerge in December, already heading away toward the interstellar infinity from which it came. We'll have only a few months to study this cosmic enigma before it becomes too faint for our instruments. The Martian flyby data is still being analyzed. Webb observations continue to reveal new details about its chemical composition. Radio telescopes are listening, computers are crunching numbers, theorists are proposing increasingly exotic models. Maybe in a few months we'll have a perfectly natural explanation for all the anomalies. Maybe we'll discover that Atlas comes from a star system with chemistry so different from ours that it produces comets that seem impossible. Maybe we'll understand that our models of the interstellar population were simply wrong. Or maybe, just maybe, we'll face something that will require rewriting the textbooks. Not necessarily in the sense of we found aliens, but in the sense that the universe is even stranger and more wonderful than we dared imagine. For now, all we can do is observe, measure, analyze. Follow the data wherever they lead, without prejudice, but also without credulity. That's how science works. One step at a time, one measurement at a time, one mystery at a time. Okay guys, is there anything you don't understand about what we've told you? Let us know in the comments. And if you want to learn more about the interstellar objects, check out the videos we've dedicated to it on the end screen.